Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher. In the yesterday's class we discussed the second colligative property, and that was elevation in boiling point. And then first of all we discussed the another colligative property, relative lowering of vapor pressure. And today we are going to discuss the third colligative property, and that is nothing but the depression of freezing point. Okay, let me write down the titles. Solutions and colligative properties. Solutions and colligative properties. So we are discussing the colligative properties. So in today's class we are going to discuss depression of freezing point, right? Yes. So just like in the yesterday's class also we have discussed, uh, in the same manner we are going to discuss about the depression of freezing point, considering the type of the solution in which there is volatile solvent and non-volatile solute, right? Okay, so first of all let us see the meaning of freezing point, right? Okay, so we have discussed the definition of freezing point in our school, that is the temperature at which the liquid freezes is called as freezing point. No, that is not the perfect definition. Let me write down the definition of freezing point first of all. Freezing point of a substance is the temperature at which the vapor pressure of that substance in its liquid state or liquid phase is equal to the vapor pressure of that same substance is equal to its vapor pressure. I will write down its vapor pressure in the solids phase. Its vapor pressure in the solid phase. This is called as the freezing point temperature, right? Okay. Now, according to the what you can say, the as I have told you about vapor pressure concept already, with the help of the experiment in which there was a volatile liquid in the beaker, and then it undergo evaporation. Rate of evaporation and condensation was exactly equal to each other at the equilibrium state, and that is nothing but the vapor pressure, right? So that part I have explained to you. So according to the similar kind of experiment performed, it was observed that the depression of freezing point of a dilute solution is depressed, right? The freezing point of the solution, when we are mixing the non-volatile solute to the solid, the vapor pressure is decreased, and as vapor pressure is decreased, therefore obviously the freezing point also will be decreased, right? Yes, so that statement I will write down here. According to Raoult's law, right? According to Raoult's law, when a non-volatile solute is mixed to the volatile solvent, the vapor pressure is decreased. We have seen the reason already. The vapor pressure is decreased, and hence the freezing point also is depressed. Instead of decrease, for freezing point we use the word depressed. Hence freezing point is depressed, right, or decreased, right? And hence we are studying the depression of freezing point. Okay. Now let us see the symbols. Now consider, or let TF naught, right? T stands for temperature, F stands for freezing, TF naught stands for the freezing point temperature of the pure solvent, right? Yes, so it is the freezing point of pure solvent. Pure solvent means without addition of non-volatile solute before, right? Then only TF stands for freezing point of solution. Freezing point of solution means what? Once we add the non-volatile solute to it, right? Yes, so TF is the freezing point of solution after addition of solute to that, right? Okay. Now therefore, how we can write down the depression? Therefore, depression of freezing point. Depression of freezing point, which is denoted by delta TF, right? It will be equal to what? As freezing point is depressed, so TF naught will come first and TF will come later, right? Okay, it is the depression of freezing point. Okay. Now, just like we have seen for the elevation and boiling point, similarly for the depression of freezing point also, the experimental observations proves that the depression of freezing point is directly proportional to molality of the solutions. Okay, yes, as depression of freezing point, depression of freezing point is nothing but delta Tf. Right, depression of freezing point, that is delta Tf for dilute solutions, right? For dilute solutions, okay, is directly proportional to, yes, it is directly proportional to what? Molality. Directly proportional to molality. Molality is also called as molal concentration, right? Molality is also called as molal concentration. Molality is denoted by small m, right? Molality, that is small m. Okay, therefore we can write down delta Tf is directly proportional to m. Here also we can write down the proportionality constant, then that is nothing but kf, k capital F small f in the subscript, multiplied by m, right? Where what is kf? So kf is nothing but the proportionality constant, or it is also called as the molal depression constant. Molal depression constant, or freezing point depression constant. Molar depression constant or freezing point depression constant, or cryoscopic constant, or cryoscopic constant. Okay, so this is nothing but your kf. Okay, yes, now let us see how to find out the unit for kf, right? Yeah, just like we have seen the unit for the elevation in boiling point, similarly we can find out the unit for this kf also, right? Okay, what we know, the equation delta Tf is equal to kf into m, right? Okay, what is m? M is the molality, right? As we know, molality is equal to number of moles of solute divided by the weight of the solvent, right? Weight of the solvent in kg, right? Weight of the solvent in kg, that is the unit for molality. So unit for this that is, unit will be mole, as number of moles, unit is mole per kg, right? Okay, so let us therefore delta Tf as it is equal to kf into m. Okay, therefore m will be equal to, kf will be equal to, you want the units of kf, right? Yes, so let us see, this is about units of kf. Kf will be equal to what? Delta Tf divided by m. Delta Tf means it is also a temperature, which is expressed in Kelvin, divided by mole per kg, right? So this mole will go up and kg also will go up, so it will be Kelvin per Kelvin into kg, right? Okay, Kelvin kg mole inverse, right? So this is the unit for kf. Okay, so yes, right, so this is the unit for kf. Okay, now you can do one thing. First of all, you just take a screenshot of this much part, and then we will see the remaining portion. Okay, now after this let us see the uh, determination of molar mass of unknown solute by using the depression of freezing point. Exactly same thing which we have discussed yesterday for elevation of boiling point. Determination of molar mass of unknown solute. Determination of molar mass of unknown solute by using depression of freezing point. Okay, by using depression of freezing point. Yes, now what we have seen, the final equation for depression of freezing point was delta TF is equal to KF into molality, right? Okay, now here molality is nothing but the number of moles of solute divided by weight of the solvent, right? Okay, now this we can modify further. For that purpose, let us assume few things. Let's consider, okay, N solute. Okay, N solute is nothing but the number of moles of solute. N solute is nothing but number of moles of solute. Okay, yes, and one more thing, just to remember. So here we are mixing solvent plus solute, right? Okay, solvent plus solute. So I am taking number 1 for solvent and number 2 for solute, right? Instead of 1 and 2, in some books the symbols X and Y are also used. So it's up to you, you can use it as per your convenience. Okay. Now after number of moles of solute, W1 is the mass of solvent, right? Number 1 is for solvent. Okay, mass of solvent. W2 is mass of solute. W2 is mass of solute. Then M2, capital M2. Capital M2 is the molecular mass, or which is also called as molar mass of solute. Okay, molar mass of solute. Okay, now let us just modify the above equation. Now therefore molality will be equal to what? Number of moles of solute divided by W1, right? Okay, if W1 is given in kg, but as I have told you many a times it is given in gram, so I'll just modify it. The conversion factor I'll add. So if it is in grams, then I have to simply multiply this by 1000, because 1 kg is equal to 1000 gram. That conversion factor I have to add here. Okay, now this again I will further modify for number of moles of solute. As we know, the formula for number of moles is equal to given mass divided by molecular mass or molar mass, right? Given mass divided by molar mass, right? So number of moles of solute will be equal to given mass, that is W1, W2, and molar mass, that is M2, right? Okay, this I can put in the above formula. Therefore above formula becomes, that is molality will be equal to, instead of number of solute I will write down W2 by M2, then divided by W1 multiplied by 1000, right? Okay, or it can be also written like this: 1000 multiplied by W2 divided by W1 multiplied by M2, right? M2 will go down. So this molality I am going to use it in now this final equation, right? Delta TF ka equation. Okay, now therefore what is the delta TF ka equation? Therefore delta TF will be equal to KF multiplied by molality, right? Molality, that is equal to KF into molality ka equation is 1000 multiplied by W2 divided by W1 into M2, right? Now we want the equation for the M2, right? Because M2 is unknown and that we want to find out. Therefore I will write down the final equation which is for M2, that is molar mass of unknown solid. It will be equal to 1000 multiplied by W2 multiplied by Kf divided by W1 into delta Tf, right? Divided by W1 into delta Tf. So this is the final equation for M2, right? This is the final equation for molar mass of unknown solute. Okay, by using this equation we can find out the molar mass of unknown solute. Okay, how to perform that experiment we have already discussed in the yesterday's session, so I am not going to explain it again. Okay, now you can just take a screenshot of this page first of all. Okay, yes, this is the final equation which we are going to use for solving the question based on this. Take a screenshot fast. Okay, now let us see one question based on this concept. How to solve the question based on the depression and freezing point. Okay, as I have told you, everything will be given and out of the formula and one thing will be asked to you. Okay, yes, so let us see one such a question. Question based on depression of freezing point. So 45 gram of ethylene glycol, 45 gram of ethylene glycol. The formula for ethylene glycol is given in the bracket. C2H6O2 is mixed with 600 gram of water. Is mixed with 600 gram of water. Full stop. Calculate first thing to calculate is freezing point depression. Calculate freezing point depression, and B is the freezing point of solution. Freezing point depression and freezing point of solution. Okay, yes, very easy. Let us see how to solve. So here we do not we have they have given like about the solute as well as solvent in detail, right? So let us see how to find out. So first of all, we can find out the molality of the solution, right? Okay, because we know the equation, final equation which we are going to use, delta TF. Okay, delta TF is equal to KF multiplied by molality, right? Delta TF is equal to KF multiplied by molality, right? Okay, now here molality should be known, right? Molality should be known to find out the delta TF. Okay, KF is also given. I'll write down the KF in the bracket. KF for this solution is 1.86 into Kelvin kg per mole. Okay, yes, so KF is given, and information for solvent and solute is given, so we can find out molality, right? Therefore, first of all, what is our first task? To find out the molality. Therefore, molality, okay, molality is equal to what? Number of moles of solute divided by mass of the solvent, right? Mass of solvent, here solvent mass is given in gram, right? Therefore we have to modify the equation further for kilogram, right? So multiplied by 1000, right? First of all, let us find out the number of moles of solute. Number of moles of solute is ethylene glycol. It is the given mass divided by its molar mass, right? Given mass divided by its molar mass, right? So given mass is 45 gram, that is given. Molar mass we can find out by using the formula. Okay, what is the formula? C2H6O2, right? Okay, therefore it is equal to 2 into atomic weight of carbon, that is 12, plus 6 into atomic weight of hydrogen, that is 1, plus 2 into atomic weight of oxygen, that is 16. So it will be equal to 24 plus 6 plus 32, right? 24 plus 6 plus 32, which is equal to 62 gram per mole, right? What is the molar mass of ethylene glycol? 62. Okay, 62. So it will be equal to 45 gram divided by 62 gram per mole. So gram will be cancelled out, and the answer is equal to 0.73 mole. Number of moles of solute will be equal to 0.73. That I can put in the molality formula. Therefore, molality will be equal to what? Number of moles of solute 0.73 divided by mass of solvent. It is given in the question. Water is solvent and 600 is the mass, right? So divided by 600. It is given in gram, so multiply the equation by 1000. Okay, so it will be equal to 1.2 mole per kilogram. This is the molality, right? Okay, molality we have find out. That molality we can write down in the delta TF ka equation, right? Okay, therefore what delta TF will be equal to? Delta TF, as delta TF ka equation we know already, KF into molality, right? KF is given in the question, that is 1.86 in 1.86 is the KF, right? Okay, 1.86 multiplied by molality is the 1.2, right? Okay, let us write down the units also. Is the Kelvin kg per mole, that is the unit for KF, right? Multiplied by molality is 1.2 mole per kg, right? So here you can see these things are cancelled out. So kg per kg cancelled out, per mole cancelled out, right? What will be answer then? As delta TF is the temperature, so it is equal to 1.86 into 1.2 Kelvin. 1.686 into 1.2 Kelvin is equal to 2.2 Kelvin. Is equal to 2.2 Kelvin. Okay, 2.2 Kelvin is the delta TF, right? Depression and freezing point is this much. Okay, now let us just highlight it. Now first part is done. We have found out the delta TF. Okay, now after delta TF we have to find out what the next part, that is the boiling point of solution, right? Okay, delta TF is the freezing point depression that we have done. Now as we know, delta TF is nothing but the TF naught minus TF, right? TF naught minus TF. So TF naught is the freezing point temperature of pure solvent. Okay, as TF naught, that is equal to freezing point of pure water, freezing point of solvent, solvent is water, water का freezing point is 273.15 Kelvin. This number you have to remember, you will require this for so many times. Therefore delta TF will be equal to what? 273.15 minus TF, right? TF we have to find out, right? Okay, so delta TF, TF will be equal to what? TF will be equal to 273.15 minus delta TF. Delta TF we have find out. What is delta TF? 2.2. 273.15 minus 2.2. It will be equal to 270.95 Kelvin. Okay, so what is the freezing point of solution? Freezing point of solution is equal to 270.95 Kelvin. Okay, yes, so thus we have find out both the answers by using the concept called as freezing point depression. Okay, yes, I hope you understood the solution part. Just take a screenshot of this page. Okay, so I hope you understood this depression and freezing point concept, and as well as the question based on it. Some other questions are also there which I have just added in the DPP. So this is daily practice problem. You can see this is the teachers portal. Similar will be yours. Just give me a second. So this is a teachers portal, similar is yours. Go to the resources, then to writing material, then you can see DPP, you can open it, download it, write down the solutions on the paper or your notebook, take a picture of your solution part and just upload it on your portal. The teacher will be able to evaluate and let you know the suggestions wherever required. Okay, so that's all about the DPP. Remaining concept related to colligative property we will discuss in tomorrow's session. Okay, thank you so much student for your precious time. Thank you so much for joining, and all the best to you.